Well, hi, good morning, and welcome to my shop and my cat. So today, what I'm going to do, I'm going to go through the alignment process on this radio. The problem here is, as I discovered yesterday, the power transformer has a defect in it, and so this radio ultimately, or because of that, is running with reduced B plus. It reduced everything in it. So how well it's going to align is a bit of a question. What are you doing? You got my tube here, buddy. I think the B plus is high enough. We will see as we go through this. So, I mean, obviously the engineers designed this radio for a certain operating point or operating condition in each one of the tubes, and it's not going to be there because the B plus is not just a little low, it's maybe 30% low in some cases, so that's quite different. Well, let's give it a go. So I think the first thing I got to do is I got to review the instructions. Oh, a little bit of CB just came through there. So we're going to take a little closer look at this radio because its tuning behavior is pretty odd. It's really not what I thought. I had guessed when you're tuning regular bands, you take the band spread pointer and stick it on 0. And the answer is no, you don't do that. In fact, if you can do it, that's right, we have to fix the string on this. That's what I'm forgetting about. Okay, give me a little bit of help here. The normal tuning of the radio, this is set to 100. And then if you want to tune something, the suggestion is you tune this pointer to the upper end of the range you're interested in. So, just as an example, right here is the 80 meter band between 3.5 and 4. The pointer's actually sitting there. To tune this band, the recommendation is you put the main pointer at the high end and then tune away with the band spread. Of course, the band spread's slipping here. Clearly that's my project today. What that tells me is, really not going to try to identify any frequencies from this band up here. I mean, look at it. How can you tell what frequency you're tuned to? And this isn't going to help. It suggests that you use the radio when you tune something in. You want to tune in again later. You use a logging technique to log numbers using the scale and other stuff. You just log a number. It's not actually the frequency. So, yeah, it's kind of a junior shortwave radio for sure. And then when you want to operate on the highest band, this one up here, the 48 megahertz to 54, to do that you kind of reverse everything. You set this to the end of this arrow, I guess about there, and now you tune entirely with this guy. Of course, he's not working. There we go. I'm turning it the wrong way. And then you can read this pointer directly from the scale. So this would be tuned to 53, something like that, 53 megahertz. Okay, good to get all this stuff straight before I launch into an alignment. Part of the alignment affects the accuracy of these pointers, for sure. Okay, that's good, but we're going to work on the string now. Okay, so not the most fun thing to do. You see, someone has made an attempt at increasing the friction here by putting some friction tape in here. I'm pretty sure that's what that is. It's a very, very long travel here, like a long piece for the string to travel along. Of course, it's not really traveling at all. So why is the tension gone from the string? Something I noticed the last time looking at it here. A little far to see through there, right between the tubes. You can see a knot on the string over here. So I think the string broke. Somebody shortened it up somehow and tied it. Now, did they alter the way the string is laid out on here? Probably not. Probably not. Well, there's a stringing diagram. I want to show something else here. Someone was asking me about crackles in their capacitor, tuning capacitor. In fact, the person's the owner of this radio was asking me about another radio. So, and I explained something to him. This is a perfect chance to explain it here. Oh, I know what I did. I spun the radio around. Where'd everything go? I was going to show. So obviously, if the plates are rubbing, then they're going to get the crackle, and that's pretty easy to figure out. What's less easy to figure out is it's still crackling, and when you tune, but there's no plates rubbing against each other at all. Everything looks perfect. The problem is probably here. So there's a clip right there, a spring clip, and it's applying pressure onto this shaft. The middle shaft is what turns when you tune the radio. And that shaft has to be grounded. That's the way virtually all radios are made. At least it has to be tied back to the frame here. And so to make the contact as good as possible, they use spring clips to put pressure on. There's usually another one over here. There is. And often there's one in the middle here, depending upon the way the capacitor's been designed. And what you do is you take a little bit of, I'm going to say it, WD-40. And spray it. Just spray it in there. Spray it in there. Work it up and down a few times. Crackle gone. That's what has to be done. But I don't think that's a problem with this radio. The problem... Oh, the string didn't change itself. I was hoping during that little talk the string would somehow change itself. So, okay, I got to study up on the string diagram. Oh my gosh, I have to take this whole front panel off. I don't think that's going to help at all. Okay, let me get the string diagram. Take a look at it. Oh, we've got some great instructions here. This is the band spread here. And a couple things to note right away is how many times around the spindle here does it go. 3 turns around. We're going to take a look at that on this radio in a second. The other thing is, how is the spring done? Now, the diagram's really hard to figure out what is going on here exactly. But we can read, because it actually has written instructions. Band spread gang fully open. Tie one end of a 36-inch length of 30-pound test dial cord to the spring at position A. So what they're telling you is tie it to the spring here, position A. Follow a stringing procedure A through L, and all they're basically saying is just run the string B, C, D, E, F, G, H. I mean, really, J. Oh, I guess J means all the way around, and then you're in. And what do you do when you go in? At position L, stretch the spring and tie the cord securely to the spring. Who are they trying to kid with this instruction? Oh my gosh, I think that would be really tough to do. There's another approach here. So really, if you think about it, both ends of the string are tied to the spring. Hope I'm getting my string and spring out there clearly. Another way to do it is you tie the string into a continuous loop, and then you just pull part of the loop down through here and attach the spring to it. You know, the string is not tied down at that point. It's actually, you know, you could actually slip it through this whole thing if you really wanted to. Fat chance on that happening. So tie it, bring it around, tie it. I have to think about that. There's no easy way to do these things, but I've seen lots where they do just what I said. It's a continuous string, and they just pull it down and hook the spring onto the loop. Let's take a look at this situation. So carefully, it comes under and then out. Okay. I should get my cat. Cats like strings. Why did the cat work on this? So I said under. Didn't I say under? This is over. 3 times around. This is going around once. Really just once. Once around. That's part of the reason why it's so slippy. It's just got nothing. Plus, because the string hasn't been taken up with an extra loop here, the tension is off. I have to replace this string so much as I have to correct the tension on it, and it could be as simple as just looping it around one more time. What do you say to that, Cat? I say I need my tools to do it. Here we are. Okay, so what we want to do, I want to try to wrap the string around one more time. Oh, wait a minute, you know what? I don't think this is on the spring at all. Oh, wait a sec. Wait 1 second here. Okay, I think a close look at this, and you can see that I can see anyway, the string is going down where it's you gotta guess there's a spring down here. We can't see it, but if I could pull on it, I could find out. If I pull on the string, should be able to tell. Oh yeah, so there's definitely a spring there. It hasn't got a lot of, almost no force. Maybe if I just double this up, we're done. Feels like there's wax all over this, or something all over it. This goes all the way down here. These blades will go. So the string is doubling over here at the end. So let's run it back the other way. There's a very long travel shaft here. What are we bumping into now? You can see I'm pulling the spring at this point. So this is up all the way. That's it. That's the end of the run. That's fine. Good grip now. Okay, but we really want this further down. So I'm going to back it up. So I want to get the travel going properly on this. It's not right now. It's over to one side. You know what I mean? Let's see if that does it. A little too far. Go back. Hit the end. This way. I think that's all it's going to take. Nothing more than that. I do have another problem with that pointer. If I remember right, it was bent funny. Okay. Hey, that's okay. I did the string. Wow. There you go. That turned out to be easy. Easy, easy, easy. Easy, easy. And it has to do with being sure what the problem really is before doing something. And what are we going to do? So we're going to watch this pointer now. Looks like it's on an angle. It just looks ugly, doesn't it? How are you ever going to fix that? This glass cover doesn't look like it wants to come off easily. This whole plate off. Take all the knobs, all the switch things off. And I could get at the pointer directly. What a hassle that is. Pointer comes up like it comes up from behind it, and then you can't access it at all. But you know what? I think I can do some bending on there. Can I get at it and bend it? That's a good question here. You can see that there's, instead of it going straight, it's going on a bit of an angle like this, and maybe that is already causing it to tip a bit. Like what I'm trying to say is, yeah, you have something like this, and you go to bend it this way. I think there's a good chance it will rotate up like this, and then you'd have the pointer pointing on an angle, but also pointing back a bit. That's exactly what this pointer's done. So why can't I just bend it? If I just bend it straight, won't it all come back? We're gonna find out. I don't want to break a pointer on a radio because radios aren't too good without pointers. This one's not even too good with a pointer. I think I need the stronger pliers. Oh, it bends as easy as can be. It's going to break right off is what it's going to do. Okay, well I got it straight now. Let's see what happened on the front end. Was my theory correct? Of course it's straight. It's still rubbing on the back though, I think. A lot better. Chance of getting it straighter than that? Looks good. Looks really good. Just that little eyepiece. And what I mean by that is, if the pointer's on an angle like that, you look at the radio, the first thing your eye's going to find is that angular pointer, because your brain is going to say, something's not right there, you better look at it. And that's the annoyance of things like this. Your automatic curiosity system starts running, and you can't shut it off. And it just becomes an annoyance. You know, eventually you get up and straighten that thing up, because I can't stand looking at it all day. So I think that's it. I think we're ready to align the radio. I really do. This is stopping at 90, not 100. Where's it stopping on the other side? Yeah, so this is out. You know, it's just a logging scale anyway. I'm not going to sweat over this. There's no accuracy in this guy. The name of the game is, does it pick anything up? Actually, that's the question. That's not the name of the game. Okay. Shadow, you're being very patient. Let's turn on this radio and see what we can get out of it again. And then we're going to start doing the alignment thing on it. Okay, I'm going to put... We'll do an antenna here first. We'll have the signal generator going in a moment here. Back it. I need to turn it on here. Oh, look who's here. What is that? Okay, that got the cat's attention. That's from Trollhättan in Sweden. Okay, we just want to put this in here. Fun at every turn, isn't it, Shadow? Okay, we're plugged in. Antenna's hooked up. The volume is turned off. Dim bulbs on for no good reason. Switch on. Here, wait, let me get that out of there. Don't sniff too much. Okay, we have full power. Yeah, we better run this guy on full power because he's on half power when it's full power. You follow that? We're on band A. Put this up at the top end. $740 if the dial's accurate. $680 if the dial's accurate. 640's wiped out, I think. I don't know. I don't know what we were listening to. And we should just run through the one shortwave band anyway at this time of day. Maybe the two of them. Band C. Band C. Oop. Lots of volume. 9 megahertz. Well, it's something. It's something. Good. That's all I need to know right now, is that it's receiving something. So we're going to put on the signal generator and we're going to start doing the alignment thing after I spend a little bit of time studying here. Shadow, do you want to study this with me? Great, thanks. Okay, so the signal from the signal generator goes into the tuning capacitor stator plates. Couldn't find the volume control there. Fed into the stator plates. Now, just looking at this capacitor, I can't tell which are which. One set here is for the local oscillator, and the other set is tuning the antenna, so to speak. Front end tuning, which is which. So if we interfere with this a little bit, one of them will cause the signal to fade out, and the other one will cause the signal to retune. Almost the same thing, but not quite. Let's see if we can figure out which is which here. Not doing much of anything there. So this is tuning. When I do this, that's the local oscillator. That's the front end tuning where we want to feed the signal into the stator plates. So we just come up here. And this goes to ground somewhere. Maybe right on the capacitor. This goes on my signal generator, but there's a cat in the way. You gonna go over top you or around you? Which one is it? We'll try going around. Okay, we'll change the operation as the ground got connected. She's just getting more comfortable. Let's turn it up a little bit. You still hear the radio signal coming through. I'm gonna get rid of the antenna. We don't want that. Now, what's going to happen here? So I'm going to tune the signal generator to feed in a 455 kilohertz signal, and we should hear something come out of the speaker. How about we do this? Put this here. A little better for you, cat. Room for all of us. Turn up the output. Oh, I hear it already. Now we'll tune. So there's a heterodyne in there. It could be because it's still picking up. So the heterodyne is the pitch going up and down. That's kind of an interference, and behind it you hear a 400 hertz tone. You can still hear the guy talking too. So it's definitely we're just picking up the carrier of the radio signal. No antenna. Well, this is acting like an antenna, I guess. Could short these out. Maybe that doesn't recommend that, so I'm going to stay away from that. Turn up the output of the signal generator a little bit higher. Kind of take over the radio. By now the AVC's kicked in. That's why the radio station, the noise went away. It's not the best way to align a radio, but it's a good starting point. And where are we starting? Okay, move this over here so you can read the frequency there, 456. Let's just, you can watch this meter. Cross your fingers on this meter here. Oh yeah, this is the one that's sticking up here. What is that? It's a very, very small voltage. Could just be kind of noise in the meter. Yeah, I don't know what's happened. Am I stuck? Maybe I'm stuck. It's just doing nothing on that meter. Loud in the shop here. Okay, we can do this. Let me do this. Do this without the speaker, without listening to the speaker. Well, let's listen just a little bit more here while I fiddle around before I... We're not doing this at the right, exactly the right... Here, wake up, Jim, come on. Okay, I think I woke up. I've calibrated my signal generator, and I now know that this is a, well, it doesn't really matter, this is a strong signal I'm using to do this. But maybe that's okay, because I'm feeding it, it's not fed into the antenna, right? Okay, so we wanted to do this at 455. I still hear a bit of heterodyne in there. And these are not through slugs. I have to get underneath the radio to do this. Start with one of these. Supposed to start with the last one first. And a good tool for this. Good and stiff, has a handle on it. Give me better control. Won't go in. No way it's going in there. It's too big. This is a crummy one. You can twist the shaft on it. But if these things turn easy, which they probably won't, look at how much play there is in it. Just looking for a big wide one. Like that. This might be ideal. Ugh. I think it's moving the slug. Feels like the slug is moving early. Easy. Okay, so I think we're ready to go, but you can see that the control has a huge amount of play in it, you know, from here to here. Like playing the steering wheel. Geez, when I was a kid, my buddy's car had more than a quarter turn of play in the steering wheel. So you're going down the highway like this. All the time. Hey, and we loved it. It was a 1964 Galaxy 500, if I remember right. Okay, so we need to know which one of these we're starting with. I'm just gonna check and see what it says. It says S1, S2, S3, S4, S5, and S6. Okay, straightforward order. Show me where these things are. S1 bottom is this guy here. S1 bottom. Just trying to feel it. There we are. Okay, that's it. I'm in. Now, meter. Add volume. The only tuning issue is this guy, and he's tuned to a fixed frequency of 455. There's nothing we really need to listen to here. It's just all about peaking that meter, which is jumping around now, doing funny things. So I'm going to disconnect the speaker here. Okay, now we're relying just on the meter. Oh boy, look at that. I'm going to turn it way up here to get any volume type response. She's pretty steady. I have to wave the frequency around a bit to just make sure that this is really what we're seeing here. Yeah. So I'll set it again, 455, even though the thing says 454. If you can read it, it's really 455 now. Okay, we're ready. 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 It's already in. Okay, first one. Watch that meter. Down. Up. Down. Just about right. Right there. It won't come out. Okay, now we do the top of that same one. Okay, we're in. We're watching the meter. Shadow, you're not watching. Down. Up. Down. Right there. No benefit from that. Okay, do the next one. Up. Bottom. Okay, we're in. Hey, Shadow, you gotta move a bit. I can't see the meter. Down, down. So again, this one's just fine. Okay, now we're ready. I just move a little to the left. Oh, you know what I can do? How about this? We just move this over here. Okay, make sure you get on the right one now. Get on the right one. There we go. Watching the meter. Up, down. So this one went up a little bit. Last one. Bottom. Scary there, Shadow? Okay, we're in. Watching the meter. Down, down. So this was right on. Down, up, and down. So this was a little bit out, but just a hair out, and of no real, I'm sure, no significance. That seemed to do nothing for this radio. That's what I think. Okay, but we've done that step now. That step is done. Next step. These are the ones I think we're really going to get a benefit out of. It's a long, drawn out procedure here, sort of. Hold on. Just one more thing here. Same as step 1. I just did step 1. S9. Set the CW AM switch to CW. reset the switch to AM when you're done. Adjust S9 for 0 beat. Oh, we have to hear it. Okay, down on the volume. Back on the speaker. So what it says here is set the CW AM switch at CW. Didn't do much. Adjust S9 for 0 beat. Don't hear any beat. Let me turn the 400 hertz off here. Well, so we're supposed to be hearing something right now. CW's on. Shouldn't matter what band we're on. Well, I'll take that back. I'm going to verify that what we're hearing is the heterodyne between the oscillator and the radio and the IF signal by changing the IF frequency, by changing my signal generator. Defender of the signal generator. Watch how easy this is. I got you on that. So hear the pitch change. So it's a heterodyne. This is exactly what the radio is supposed to be doing, just that it's supposed to be at 0 beat. Don't stick your nose in there. What are you sniffing? Something burning? Go back over here and play with stuff. Here, play with this tape. Look at this. Good, that should keep you occupied. Did not put the capacitor in when I did that. Adjustment. Well, the adjustment amounted to nothing on the IF. I don't think it matters. I think we're okay. I actually do have a capacitor. It's in a box that she's sitting on right now. So, S9. I have to find S9. S9. Okay, S9 is that thing that's out in the middle of the chassis here all by its lonesome. There it is. That was just that was a nerve thing in my wrist. It wasn't a shock. That's 0 beat. That's it for that adjustment. What's next? That's it. Next is now we do some antenna stuff. Okay, we're ready here for step 1. So I followed their instructions. My signal generator is connected to the antenna through a 300 ohm resistor back here. As the cat slinks by. 300 ohm resistor. This is just a capacitor to nowhere. Signal generator grounded to the chassis. Where are you going? There's nowhere for you to go out there. You know what? I have to grab her because I know the next sound I'm going to hear is something crashing through the floor. It might be her. Come on out of here. You're out. How about going back here? Start over. Such distractions. Right, so I have the signal generator connected to the antenna. Nothing else going on here. I'm going to tune this to 1500. Signal generator is running at 1500 right now. Hard to read the number, but it's 1500. And we should hear it out here. Oh, I still have this on. I'll knock that off. I don't think I heard it. Okay, hold on. Signal generator has no tone. Did you do that, Shadow? Okay, 1000 hertz tone. Turned it up 10 times as strong. Oh, that's not it, is it? What is that? Well, that sounds like a ham radio transmission being picked up with virtually no antenna here. How come no signal generator? Let's go a little stronger. Oh, there it is now. It's pretty much right on the 15. This band spread should be all the way. Yeah, all the way is 90 now. Well, first adjustment would be an oscillator adjustment to correct the pointer accuracy. What else are we doing up here? We're doing A and B maximum output. Receiver dial setting 1.5 megacycles. A and B. What are A and B? A and B. Oh, okay. So A and B are. This radio is just a huge pile of capacitor adjustments here. A and B are the first two up here. A and B. Okay, hey meter. With the speaker. Watching the meter. Going down. Going up. Going up. Going up. Up, up, up. Uh-oh. So I basically opened this capacitor as pretty much as far as it'll go. That's not a good sign. Down. And we'll leave it like that for now. The other one. And you like to see a peak form when you do these things. Whoa, whoa. Hair trigger on this one. Seem to be aligned correctly. So what have I done exactly now? Is that the A band? Just do AB. Oh, and now what? Go to 600 kilohertz. Go to the other end of the band. .6. Go down to 600 and adjust C. 600. You're pushing on me, cat. I don't know if you can you see the meter? As I approached the 600, the meter came up. 600. Okay. And it went back down a bit. So now I'm supposed to adjust C. And C is where? Okay, so C is the inboard second. Inboard second. This one. Okay, watching the meter. Down. Up, 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 down. Right there. Got a little bit out of that. All I'm doing though is I'm tuning the radio, so it's not actually increasing the sensitivity of the radio. I'm just hitting this, getting it to tune in the signal generator right on 600. Let's put the antenna on, just see where we're at here. Let's do that. Yeehaw. Still hear the signal generator. So I think it's picking the signals up where they should. There's 590. 680. But reception's nothing to write home about, that's for sure. What else we got to do on that band? Nothing. Yikes. They're not being very specific here about what it is you're actually adjusting. They're just like what the circuit effect is. Well, not in this. There's really not much more I can do for this radio. That's really disappointing. You know what we can do? We can hook up a real McCoy loop antenna to this radio and see what happens. Let's do that. Okay, I think I've sorted out things with the loop antenna. .680, rated 680. Very good. Still can't get 640 because of the noise right on top of it there. I had a big couple of big military radios in my shop here the last few weeks, and for them, wow, separating out that noise from that signal is nothing. It's nothing to it. This radio can also, it's simple enough. It doesn't have a front end RF amplifier tube, extra tune circuit at the front. This thing could be susceptible to all kinds of wild interference signals in it. No directionality, there's no tuning. I think it has something to do with the radio. I've put that antenna on many radios, and often you saw me tuning the capacitor. It's really sharp and very distinct when you get the antenna tuned. Not so with this radio. I don't know what's going on, but that's par for the course. Okay, I think the AM is working fine. I'm happy with that. Let's go on to band B. Band B. Hello, hello. Come in radio. Ooh, oh my gosh, it's way out. 6.5. How much I want to bet this thing is going to align with the band spread at 0. Okay, now where is it? Well, if you haven't caught on, this meter gets pinned at right there. There's something that has fallen down in here and is blocking it from. I don't know what that is. So, well, what to think about that now? It makes a load sense more to me to do this thing at zero. And obviously it made sense to somebody else too. Well, let's do a little experiment here. You can see the volume of the radio is coming up to just under -6 here. Minus 6.5 is where it is. So what happens if I tune this to the other end and then tune the radio to find it again? Do we get the same signal strength? More, if anything. So that's -6 now. Oops, wrong one. So you got -6, and here I've got -7. Well, no. So if somebody has aligned the radio this way, yet I can get more signal with it up here, I should follow the instructions. Put this up here and align this back to 6 by making the adjustment. I can't really think my way through this. I can't be sure what I'm thinking, so I'm just going to try to follow the instructions. So we want this to sound like 6 now. So the first thing we're going to adjust here, let me just peek at the guide. Decisions all the time. D and E are what we're supposed to do. D, inboard third from front. Inboard third from front. So conceivably this is an oscillator adjustment. And we're going to find out before I mess this up. We're going to tune it in. Then we're going to adjust it a little bit and see if that's really what it is. Yeah, sure sounded like it. Yeah, went the wrong way. Okay, so now we're at 6. This is all the way that way. Okay, watch the meter now. Okay, see, look at it, we're getting a lot more. Not a lot more, but we're getting more. -5. And then the other adjustment is E. E is third from the front outboard side. Okay, watching the meter again. Down. Up. Six. Top of the band. Okay. Next band. Go here. Suggest doing this one at 15 megacycles. 15 megacycles, 15 kilocycles. Happens to be just about exactly where it was. That's 15. Didn't hear a thing. A little more volume. We're at 15.2. So I will just go ahead and do the procedure. F is these things are out of order. F is inboard last. That's this one. Come on, get in there. Okay. Now watch the meter. Wow. Okay, we're not gonna This is not going to get any better. Okay, well that'd be it. That'd be it for that. Next band. E. Did I do F and G? Did I do that right? 1 second here. Oh, I didn't do that right. G. Last outboard. Did I not do this right one time? I think that, no? Oh, this can't be right. Oh yeah. So what happened there? So that's G I was just turning. It's F and G, isn't it? F and G at 15 megahertz. F and G. I don't know what I did. Did I do E again by accident? I don't know. That's it for this band though. 30 megacycles. Next band. We're getting pretty high for a radio. Again, I barely touched this. 30. Getting high for my signal generator too. 30. Let's see if we can get there. Yep. Pretty darn close. That's 30, just a little above 30. I mean, the width of the pointer here. Put this right on 30. Find it. It's still dead on the 30 mark here. So I just need to tune this in absolutely perfectly. Okay, and the adjustment for this, you skip the I adjustment and do the H. H is where? H is inboard third from the F, inboard third from the F here. This special coded talk here. Watching the meter. This hasn't been done for a while because the screws are, they're stuck. Pop a little bit. This is dead on though. So what was it about the one band seemed to be aligned at the 0? The rest of these were already aligned at the 100. That's a little odd. Okay, and the last thing is that super high band. Probably has special instructions. Same as step 3. 52 megacycles. Dial these both to 52. So this guy, he goes to the end here, where that arrow is pointing. Set main tuning. Okay, and then this is supposed to be set to 52 megacycles. So now we look right on the thing. Here's 52. 52. The string is wrapped around this one backwards, but I didn't mention that, but it's wrapped backwards, and you can tell it's going the wrong way. Doesn't matter though. 52 megahertz right there. Oh, now can my signal generator get up to 52 megahertz? That's a little tough on it here. What happened to it? Did I just blow up my signal generator? What happened? Yikes. What happened? I don't know what happened there, but I can't get up to 52. So what we're going to do here is turn up the noise. No one's ever going to listen to this band anyway. J and K. K. Which one's K? K is second one from the front on the outside. What happens when you turn this? I was hoping the hiss would go up and down or something, but no. There's nothing up there to hear anyway. Fat chance this radio ever actually really worked well up on that band. So now I may have bumped up the E by accident, and the E goes with 6 megahertz. So let's go down to 6 megahertz. Broadcast 6 megahertz. 10. Oops. Or as far as we can get. 6 megahertz. Ooh, that was 6.8. Just blew through there. Oh yeah, this thing's got lots of image problems, this little radio. Again, it's got no front end too. It's going to have image problems. Okay, 6. So it's 6 on the generator here. I think I did move the E. The E, middle of the outboard. Maybe not. And the other one that goes in is F. Okay. Just double check. This might help a little bit. Ooh, didn't do anything. Whoa, 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 whoa. Danger, danger, danger. D, Jim, not F. Now I moved F. F is an oscillator. I gotta worry much about it. D, I shouldn't really worry about D either, but let's do that. D, middle of the inboard. Can't be. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. What's the matter with me? D, 1, 2, 3. I didn't pay attention in grade 3 for a while. Now I'm really paying the price. So don't jump up and down about this. This is just tuning the radio. One more band, and there's no antenna on this radio. Listen to it. Crazy guy. So we're band C, 14 megahertz. Let's put the antenna on it, and okay, so this is the outdoor antenna I'm talking about. So we're on 15 megahertz area. Not a thing. Tone low. Finally, something. So if this were my radio, what I'd be doing is I'd keep this in the middle, like this, and then I would tune them and then fine tune them.
When Moses gave that in Deuteronomy 6 and 4, he went on to say, and you will teach your children this, and you'll write it on the doorpost. That Yahweh alone is our God. That's there's no room for anything else, and no one else as God in that understanding. How beautiful is that? Now we know who to glorify. We know who to sing.
Just do a few experiments here with this antenna. So this is going out to a folded dipole balanced antenna, but this is coming from a cable. This is the shield on the cable, so it's not a flat lead or something like that all the way to here. Of course, it's just coming in on this cable, long cable. So this is the. So either one of these should sound kind of the same. Whoops, I gotta see what I'm doing here.
Moses, we can cite Jesus. Wow. 10 words change your life about Jesus.
So I don't hear any difference. Now we're gonna open this link here. Now, the proper way to do this now is like this.
Oh, that's so confusing. But you're the Christ of God. You are the Christ, the Son of the living God. Not the living God, but you are the Christ, the anointed Jesus. And Jesus said, hey, he confirmed that with Peter, didn't he? The 16
Didn't like that. That's the same,
and of Jesus, our Lord.
but that's not.
16 words, the words of Jesus, the creed of Jesus. And I think that's what should be us.
Well, it's a little confusing to me. Because I would have thought you'd get a good signal like this. You get a better one if you do that. Well, I don't know what to say. It's working. And I think, different radios seem to behave differently when it comes to these antenna connections and that. And there's various ways that radios are designed, of course, for the antenna connection. So that's some variation comes from that. But then there seems to be more to it. So you sort of never know what you're going to get when you hook an antenna up to a radio. Yeah, at least I never know. Okay, I think we've reached the end of the road here with this guy. I can't think of anything I can do that's going to improve its performance. It's somewhat limited anyway, as I've said a number of times. It doesn't have a front end tube, which really separates the men from the boys when it comes to these radios. So the consequences of that are probably lots of image signals in here and the like. But certainly, you can tune this radio, pick stuff up, and listen to it. No doubt about that. Okay, great. Well, thanks a lot for watching this series, and I got a big old radio coming in here next.